had about a 2-year timeline from when they made an agreement on what the changes needed to be, what the targets needed to be for the international community to, say, keep climate change under 2 degrees Celsius. The targets were getting clearer, but the Kyoto Protocol, which was the framework that they were working on, was due to expire at the end of 2012. And so they knew that they needed 2 years for everybody. Once they even agreed on it, they would need 2 years for all these governments to go back, right, and especially the democratic governments, to get the legislation passed in their own states, right, and to get the legislation so that it was ratified so that the treaty would take hold. So they knew they had a 2-year window. Now, if you go backwards from 2012, right, the beginning of 2010 is when you had to have things on the table. So mid-December 2009 is when this meeting takes place. And the expectations were very high. If you remember what happened at the time, absolutely nothing. The heads of state all flew in, right? President Obama showed up, and there was no agreement. In the end, they came out with the Copenhagen Accord, which declares that we all agree that later we should come up with binding targets. And so using international law is not going to be an easy situation when the treaty process has stalled out to some extent, right? I mean, now the Kyoto protocols are not on the table. They've expired. And along with that, we don't really see the type of support in the US. And to be clear, we have not seen that type of support. And I'll get to that a bit more in a moment. But even going back to the 1997 negotiations when the Kyoto Protocol was first drafted, right before then Vice President Al Gore went to the Kyoto meeting, the Senate passed a resolution. And you'll start to notice a pattern here. They passed it unanimously. Now, think about this for a second. In the United States, we don't get to hear a whole lot about unanimous agreement between parties. But when you start talking about climate change, we've had 2 issues that I've talked about today. Both of them have unanimous agreement. The Senate said, if you do not have a target that binds China and India, don't bring it to us. We won't ratify it, right? And if you're at all familiar with the Kyoto protocols, you know that then Vice President Al Gore, went and negotiated a treaty that exempted China and India from any binding targets, placed binding targets on the US, and when they came home, not only did members of their delegation resign in protest, President Clinton never even presented it to the Senate to try to ratify it. What would be the point? He knew. They already told him 95-0. Don't bother. We're not going to ratify it. So it's not as though the legislative support is there for some administrations and not others. But maybe you're thinking, and the pathway that I think we often turn to is, in a democracy, right, we should look at public opinion. Right? It's starting to look more and more like Congress is where the change is going to have to happen. And if Congress is where it's going to have to happen, presumably public opinion is going to be one of the major mechanisms that will convince members of Congress to act. So, this is a study done yearly by the Yale Project for the Communication of Climate Change. And they kind of take their big survey and they use a really sophisticated methodology that then kind of groups everybody according to like opinions. So it's a series of questions. And what they find are different groups that fit along a spectrum where we have kind of the alarmed group on your left and the dismissive group on your right. And the first thing we tend to notice about this is if you were to sort of draw a line right down the middle, what you would have is really only about 30% that are disengaged, doubtful, or dismissive. Subtract 30% from 100%, and it seems like 70% are at least cautious, concerned, or out and out alarmed. But I want us to pause for a second because this doesn't tell us the whole story, right? And this is part of why we want to be careful with public opinions, because here, the beliefs that people may express, right, their belief in global warming, doesn't necessarily translate into support for policy, right? And that's what we're going to try to make sense of here in the next slides. So if we look at a timeline over the past 7 years, and you can actually go back a bit further, but 2007 was the high point for public opinion on climate change. If you think of what's going on in 2007, right? 2007, Al Gore comes out with a movie called An Inconvenient Truth, which, if I'm not mistaken, won an Oscar? No, he won a film award, but he also, for his contribution, won part of a Nobel Peace Prize, along with the International Panel on Climate Change. So there's a great deal of fanfare, right? I mean, to win a Nobel Prize at least draws a lot of attention to the issue. The film itself drew a lot of attention. But the measurements start at the top of that. That's as high as it's going to get, 77% solid evidence. And lo and behold, we can probably guess what starts to explain some of the drop in the recovery. Right? That fits remarkably well with a recession. Right? That's approximately the timeline for the recession. It also happens to be the timeline, though, for the presidency of Barack Obama, a president who said he would come into office and change the direction of the oceans rising. But in an analysis of how frequently he talked about climate change, the issue pretty much disappeared after he was elected. And as a political scientist, right, one of the things that have been studied anyways is the impact it has when elected officials, especially people in high office, don't talk about an issue. It tends to disappear, right? And so that also contributes to this. So we have the recession, we have elite, right? We have the elite opinion makers that aren't really giving enough kind of discussion to the issue, and so this helps explain why public opinion shifts. Some of the recovery we can also talk about being from the recession. It also, I didn't include the slide, but there's a almost perfect overlap as well. If you want to look at the 1 year that carbon emissions actually decrease, 2008, 2009. There's a decrease between those years. And after that, they go right back on going up. So if you compare, though, what looks to be a high level of support on the previous slide with a different set of polls. This set of polls asks the question differently. Instead of saying, do you support doing something about climate change, this one says, what are you willing to support most? Right? You have a finite amount of attention, you have a finite amount of resources, what's most important? Lo and behold, strengthening the economy comes first, and it has since the recession started. Improving the job situation, reducing the budget deficit has gained in attention. Protecting the environment has even improved. Dealing with the energy problem has gone down. But poor global warming is the lowly issue down at the very bottom, which I always find interesting that it is a full 5 spots after dealing with moral breakdown. So what we want to keep in mind about public opinion and rebuilding our infrastructures, yes, we are reliant on, at this point it looks like we're reliant on Congress to pass legislation. Public opinion sends mixed signals, right? It doesn't send a clear signal that yes, people support it. It sends a signal that yes, people support it, but we also like a lot of other things more, right? And so if you're a politician, do you want to risk your career and say, well, I'm going to go out on a limb on this one, right? I mean, you think you're interpreting it correctly, but it's not entirely certain that you are, right? People are saying they support it, but when asked about other things, it finishes so far in dead last over the course of years. Now I'm going to switch gears a bit. And we're going to talk about what I see as the second problem. The second basic problem that we are confronting when we try to sort of adapt the Constitution or adjust the Constitution to deal with climate change. And that is, we have to deal in some way with the problem of science in a democracy. And I think that this is something that's relatively new on the horizon, at least amongst researchers, and it comes out of a great deal of frustration, right? The frustration was that it seemed so close, right? It seemed like climate policy was so close to forming, right? Fall 2009, there's ideas floating around in the Senate about how to draw up a cap and trade bill, right? June 2009, the House had already passed a national cap and trade bill. So at the time, a lot of researchers, myself included, were paying close attention saying, what's going to happen, right? What is public opinion finally shifting the debate a bit? Are politicians going to listen? Don't forget, I said 2009 was also the Copenhagen year. And then at the end of 2009, the House bill dies, right? Because there's no Senate bill. Obama's in the middle of a deep battle over health care. He's not dealing with climate change anytime soon. And the international treaty sort of falling apart. And so a lot of researchers are thinking to themselves, what went wrong? And especially a lot of scientists. If you go back and look at the journal Science or the journal Nature, there's actually a number of articles that show up about, are we just not communicating well, right? I mean, as climatologists, are we just not getting our message out there very well? And so this idea of, well, maybe people just aren't hearing what we're saying. And so I want to say that some of the research we're seeing now says people are hearing it, but they're not hearing it the way we expect them to. So let me try to help illustrate what I see as the basic tension between science and democracy. Imagine for a moment, right, that you are in need of making a very important decision, right? Let's say you're finishing a building and you need to put an air conditioning unit up on top, a large industrial air conditioner. You need to set it on the roof. Sorry, my father's a crane operator, so I think in crane terms. And you call, and the crane company, right, says, well, tomorrow is the only day we have the crane that's heavy enough, that can lift a load big enough to do it. And otherwise, we're booked up for a few more weeks after that, right? We only got one crane big enough, and then it's booked up. So, as with anyone who needs to make a big decision, what do? You call your favorite meteorologist. You say, listen, I can't afford to wait. I cannot put this off, right? We have this project. We're so close to being done. I can't afford to mess up the timeline on this. I got one day. What's it look like tomorrow? And they say, well, it's a 50% chance of severe thunderstorms. But if they miss you, it'll be a nice calm day. Now, if you think about that for a second, how do you make a decision there? How do you decide that? Here you're dealing in similar terms to climate scientists with a forecast, right? It's a probability. You have to make a decision, and you can't say, well, I'll half do it and half not, right? You've got to call the crane company and schedule this. And of course, let's say you cancel, you call the crane company, like, you know what, just can't do it. I'm going to have to wait and just take the hit on my subcontractors, right? But huge thunderstorm, knocks over all kinds of towers, and you're like, great decision on my part, right? What if you cancel it and there's no thunderstorm? What do you think? Darn meteorologist, right? They're always wrong with those forecasts. But what I'm trying to get at is the forecast is a fundamentally different way of approaching the problem from what you need, right? You are right or wrong as a decision maker for your company in a different way than the scientist is right or wrong. And that's an important distinction, right? The forecast isn't really put in the same terms as what you're talking about. And you could call, right? Let's say you call back the meteorologist and say, listen, I 50-50, can you just tell me what it's really going to do tomorrow? Now, you can ask them all day for an answer. But the only way they can give you an answer is to sort of take off their scientist hat, right? And make the decision for you. In some ways, that's kind of what we're doing to scientists with climate change. We're asking them to forecast, to develop these very sophisticated models about the future, but in doing so, we then put them in a policy position to say, we need to know what's going to happen, right? We need to know really what's going to happen, right? I get that you're saying like there's a chance that it'll be between 2 degrees and 11 degrees change, but really what's going to happen? And what they're telling us is, well, we have probabilities. So let's break this down a bit, right? In the realm of science, the models that they're using are going to combine measurements, right, from within the atmosphere, and in this case, broken up into a grid, right, that they're going to try to combine the physical laws that govern chemistry, right, atmospheric physics, and they're going to combine those with their sort of best theories, right, the theories that they have kind of worked through the clearest. They're going to use the best observed data they have, right? They're going to use their recorded data from, in this case, right, when we think about climate change, maybe they use ice core samples, right, to try to understand how climate has changed over hundreds of thousands of years. But because they are models, they're approximations. And if they're approximations, right, the scientists need to use the probabilities to try to express what's the uncertainty around that approximation, right? They don't put the uncertainty there to mess with you. They put it there to be accurate as they possibly can with what they know. Now, think about that in contrast to democracy. Democracy is a bit different, right? Kind of basic tenet of democracy is that laws are expected to apply equally to everyone. I mean, think in this case of the 14th Amendment, right? But politics become necessary, and in this case we have David's painting of the tennis court oath during the French Revolution. Right? But politics become necessary when we have disagreements. And we have different perspectives that lead to these disagreements. And if it's an important enough issue, we don't always find a compromise. And when we don't find a compromise, we tend to have to just decide things by a bare majority. Right? And that's not always the best way to do it, but that's sometimes what you have to do. But to prevent those disagreements over these really important issues from kind of disrupting the political process for long periods of time, the decisions that are made need to be perceived as legitimate. And so science operates in the currency of accuracy. Democracy uses the currency of legitimacy, and those are two very different currencies. So, to break that down again, right? Science uses models. The models are approximations that have to have some degree of uncertainty, and to be accurate about it, scientists have relied on probabilities. Democracy, right? We need equality, but within that equality we disagree. If we were unequal, right, then presumably the more powerful would just impose their agreement. But we're equals, so we try to disagree in a rational way. We have to eventually arrive at some decision, some policy, some law, but in doing so, it needs to be perceived as legitimate. But in the end, it's going to get translated into a rule, and that rule is a declaration, right? It has to be declared. After